Hi and welcome. I'm trying to learn particle physics today beyond four forces, and after we've done it, we're gonna do tiptoe yoga. And if you participate in the tiptoe yoga, then it's better on this. And this is part 2. In 2015, a team led by Attila Krasznahorkai at the Institute for Nuclear Research at the Hungarian Academy of Sciences spotted anomalies in the decay of short-lived nuclei of the unstable isotope beryllium-8. These seem to indicate the interferences of an even shorter-lived, slow-moving particle, a little more than 30 times the mass of an electron. So 2015 at the Hungarian Academy of Science there was someone, and they had beryllium-8, which is a short-living atom type, and it was decaying, seemed to indicate the interference of an even shorter-lived, slow-moving particle, a little more than 30 times the mass of an electron. With the interference happening in it, I don't know if it's the same as interference, having an influence somehow on that, and that would live even shorter as beryllium-8. It looked like a force-carrying boson, but one that interacts very weakly. Just a thing for explaining dark matter's dividend interaction with the rest of the cosmos. So maybe that is a force-carrying boson, interacting only weakly, which could explain something about dark matter maybe. That is all about it. We try to find out the story of the universe told by our standard cosmology is a ripping yarn, but with implausible plot twists such as dark matter, dark energy, and inflation. It doesn't quite add up. So I want to understand, in this article they are just talking about it, how the universe is, because the way it is explained is a bit implausible, or it's a bit strange, because the way of dark matter and dark energy and inflation are then explained a bit out of the ordinary, without, so something like that. Around they are talking about the explanations for how the cosmos is seem a bit strange to be talking about, and they are thinking maybe there is more than a fourth force in the universe, having to do with the dark matter or other things. The first part of the entry was about that maybe gravity, because gravity seems to be the one which might be the suspect for maybe that there's more to gravity, which would explain the more to dark matter and dark energy and inflation. Now we're talking about maybe we found a boson or something. The researchers speculated that it could be a dark photon, a new particle that might transmit a force between dark matter particles. Theorist Jonathan Feng at the University of California, Irvine, reckons the team's find is consistent with the existence of a protophobic X-boson that interacts over short distances with the neutrons within the atomic nucleus in a new way. So we're saying maybe there is, by the beryllium-8, the way how it is decaying so fast, there is a dark boson, a boson which is specifically working with dark matter. Now someone is saying the team's find is consistent with the existence of a protophobic X-boson that interacts over short distances with the neutrons within the atomic nucleus in a new way. So there is a protophobic X-boson, so a boson which doesn't like protons, and it is interacting between the neutrons inside of an atomic nucleus. That would be a startling find, and the idea has its critics. Wilczek points out that there are two kinds of things you can add to the standard model that haven't been observed, but would be consistent with everything we have observed. So Wilczek says, maybe it doesn't make sense, but they are saying now here, there are two things able to add to the standard model which would be consistent with the other things said. That would be very heavy particles which would carry a short-range force over very light particles that would mediate a long-range force. Let's read it again. So heavy particles, so big heavy particles, let's assume they're big, heavy particles, let's not assume they're big, heavy particles which would carry a short-range force. So heavy particles which could move only a little bit, I guess, does it mean a shorter range force? Or the other idea would be very light particles that would mediate a long range force. Okay, two different particles. I thought the way the first one would be the very heavy particle would carry only a shorter range force, but somehow would that make it able to mediate a long range force? Because it is of short distance pushing sort or something. I don't know. So now it makes sense, two different particles. The first one, heavy, short range, and the other one, light, long range force. And that would my other idea somehow make sense? The proposed new particle seems to be neither. If confirmed, so the new particle is neither of these two, so the new particle wouldn't be consisting with, no, they say the two ideas we have for new particles which would be consisting with a particle with a standard model of particle physics or something, are not the one which was there maybe found. It confirmed that this particle would account among the great surprises that experiments occasionally throw at theorists, a new force that interacted so weakly with ordinary matter that we just hadn't spotted it. So they said maybe that is something so weakly interacting that it was only now discovered in 2015. The Rex and Barrage, meanwhile, are investigating the possibility of a type of fifth force. So we had already four. I thought just before we found the fourth one, we're searching for the fifth one. Now we are searching for a fifth force that adopts a different disguise. So a fifth force to researching. It has large effects, but those effects are screened by gravity. So I think there is a fifth force, maybe, which has big effects, but gravity is covering them up. It is known as a chameleon force, and the idea is that the particle transmitting it changes its mass depending on the local density of matter. The idea is that the particle transmitting it changes its mass depending on the local density of matter. So there's a particle which is transporting it. But that particle which is transporting it changes its mass depending on how dense the area is in which it is. If a ship is going through water, it takes a little bit of water with it, I think. Or at least it looks like that. If a ship would go through denser water, through colder water maybe, or through salty cold water, then I guess it would take more water with it. So whatever, I just found the idea interesting. I'm pretty sure it would make sense that there are situations in which a ship takes water with it. At least if you triplets or droplets, whatever it's called, certainly. And water must have different densities, depending on how warm it is, maybe even the salinity or something. So one could say the ship going along for different places takes more water with it, depending on what place it is driving through. I don't know, but maybe it helps to understand the other thing. The other idea. Chameleon particles would be heavier where the average matter density is high, as it is, for example, around Earth, meaning the force associated with them would have a smaller range in our neighborhood, and so would be particularly invisible to us. Practically invisible to us. So heavier where the average density is high. And if they are heavier, they have a smaller range. Is that a law? Has someone proven it? That the heavier things, because that is consistently during the hypothetical ideas. So that must be obviously a law that the heavier the particle is, the smaller the force can do. The other ideas, what I just, with the other idea where I read it more, maybe it has just a little bit difference, but it has with a great mass and a great impact. Now, near Earth, this particle would be in an area with a lot of matter, therefore being heavy, therefore having just a small range, which would make it so hard to spot on Earth. The mass of these, we don't have much time left. The mass of these particles would be much smaller in vast swaths of empty space, between galaxies. It would be very, very big in the places where after the universe has expanded, no matter yet exists. Now, the mass of these particles would be much smaller in the vast swaths of empty space between galaxies where they would have a larger range of influence. Just the ticket to explain the dark energy effect of distant galaxies racing away from us. Whatever, then in places where lasers would be made more faster. From us, ever faster, obviously, it's going fast. That would explain something. Okay, the last word. We are not just from us, ever, but ever faster. Faster is on the other side. Faster, it means that could be an explanation why the universe is expanding faster. Because the more it is expanded, the less matter is there, and the easier can it put apart. I think that's also the case with rubber or something, with gum or something. The more it goes apart, the less there is in the center pulling it together, and the easier it goes apart. What if one day there is nothing anymore and it is making a big bang again, then we're having the oscillating universe maybe? Okay. A chameleon force might even, under certain circumstances, change its strength so it assists gravity rather than counteracting it, and so bag two birds with one stone by also addressing dark matter. Why? Because it would change its strength and maybe even assist gravity, which would then explain dark matter. No, we're going to read it on the next part. If you were here for particle physics, you can go directly to the next part of particle physics where we're going to read on. If you stay here and participate in the tip, you're going to set your own risk. The feet are standing together, releasing the arms up, come up on the tiptoes. Out and down. In and up. Out and down. In and up. Out, open to the side. In and up. Out, open to the other side. In and up. Make an inch of space between the feet. Open again to the side. In and up. And out and down. In and up. Out, open to the side. In and up. Out and down. In and up. And out, lean onto the knees. You can put the heels down. Breathe in. Out, make a head of the back. In middle. Out the belly. In middle. Out the heel. In middle. Out the belly. Try to come always to the big toes of the weight. Middle. And come with a round back up at the top of backward shoulder down. In the arms up on the tiptoe. Out, sink down, this can go onto the knees. Up again. Hands down, heels down. And the legs back up. One foot faces in front, the other one to the side, in the arms up. And out, bend the front leg, come up onto tiptoe with the front leg. Breathe in, reach in front. Out and back. In, straighten the front leg. Out and back, down, middle, heel down. To the other side, breathe in. Out, bend the front leg, come up on the tiptoe. In, reach in front. Out and back. In, straighten the front leg. Out, back, down, middle, down. The torso pointing to the outside. In, the arms up on the tiptoe. Out, sink down. In and up. And push something imaginary heavy upwards. And down. In and up. Out and down. In and up. Out and down. And the last time. In and up. Out. Hands down, heels down. Have the feet standing together. In the arms up. And out and down, heels down, feet together. Breathe in. Out, stretch the left leg. In middle. Out, stretch the right one. Middle. Out and down. Open the feet to the sides. Breathe again. Out, go over to one leg. Breathe in. Out, over to the other one. Breathe in. Out to the middle, close the feet. Breathe again. And out. Again in. And out, come slowly with a round back up at the top of the backward shoulder roll. in the arms up. Bring the hands to touch and now the hands down to heart center. That was the Tip Yoga. I thank you very much and until the next time.